This function has three properties that no other function has. You can find another function having these properties. So the first one is product. Second one is quotient. And the third one is power. I'll explain all three in a second. And the last one is the change of base. You could say the change of base is redundant because my calculator allows me to put any base I want. True. I'm sure that the sophisticated ones allow you to do that. However, we need to know the change of base. So for example, if I want to find log base 3 of 7, and you say, oh, there's no problem. You just write it as y, like we just did a few minutes ago. And then you will change this into raised to y equals 7. But you can do whatever you want to do. There's no way we can find this. Right? 3 raised to what number is 7? I know it's less than 2 because 3 squared would be 9. But how much it is, I have no clue. So, in the graphing calculator, in the simple ones, basic ones, like the one I have, I don't have the possibility of changing the base in this calculator. I only have log or ln. So I need to know the change of base formula if I want to calculate this, because I will change it either into base 10 or base e. It doesn't matter which one. So here's the formula. Log base 3 of 7 is a ratio. Which log you want to use? Common log, which is base 10, or natural log, which is base e? Okay, let's use both. Because Chris said natural log, you said common log. Let's use both. The answer has to be only one. We will never find two numbers that I raise 3 to get 7. There's only one number. So here's log of the number over log of the previous base, or natural log of the number of the natural log of the previous base. This is the change of base formula. And the answer will be identical. So if I have log 7, close the parenthesis, divided by log 3, close the parenthesis, or I have natural log 7, close the parenthesis, and divide by natural log 3, close the parenthesis, I have to get the same number, no matter what. I knew it was going to be less than 2, but I didn't know how much. So the answer is 1.77 approximately. How will I check this answer? How will I check this answer? This is equivalent to exactly raised to 1.77 has to be 7. In order not to have any error, here's how I will do this. I will put 3 caret previous answer so that the calculator takes it all. No approximation. And when I hit enter, what should I get? 7. Now if I raise 3 to 1.77, do you think I'm going to get 7? No, of course not. I'm not going to. I'm going to get 6.99. So let's come back to those 3 properties. So in general, let's write the change of base formula in general. Log base A of x, assuming I want to change it into base B, then I have log base B of x over log base B of A. Log base A of x is the ratio of log base B of x over log base B of the previous base, which was A. Okay, so now finally let's come back to the product, quotient, and power rules. Okay, product. Again, this is an amazing function. So let's say log in any base, log base A of a product. This is the same with log base a of x plus log base a of y. We are not distributing log to x or to y. Do not think in those terms. I'm not saying you are. I'm just saying do not think in those terms. This is not what we're trying to do. This is a property that unique to log. So in other words, as a numerical example, log base 3, let's say of 3 times 9 can be rewritten as log base 3 of 3 plus log base 3 of 9. Log base 3 of 3 will be 3 raised to which power is 3, which is 3 raised to which power is 3, 1, plus 3 raised to which power is 9. So the answer will be 3. That's the product rule. Quotient rule. So log base a over quotient. Please observe something. This is log applied to a ratio, not ever to be confused with this, which is a ratio of 2 logs. This is a ratio of 2 logs. This is not that. This is log applied to a ratio. What do you think? A wild guess. Look at the product rule and just try to come up with a quotient rule. What do you think will be different? Say it again. Exactly. Log base a of x minus log base a of y. Indeed. This is the quotient rule. Last one, power rule. Here's the power rule. Log base a of x raised to a power b. So this number goes in front as a factor, meaning multiplication, not addition, subtraction, or anything like that. So it's b times log base a of x. This property you will see in Calc 1 almost every other day. Very, very often. Okay, let's apply these properties in condensing and expanding. Okay, page 329. Let's start by expanding and then condensing. What does that mean? We'll see in a moment. So let's say, let's start with 30. Log base a of x squared divided by y z to the third. Remember, we have 3 properties. 1 for the quotient, 1 for the product, and 1 for the power. Ready? Okay. I always start, if there is a quotient, I will always have to start with a quotient. So imagine I have log base a of something over something. So this is what? Very good. Excellent. That's my first step. I finish with the quotient rule. Now I look at the first one. It does not have a product, but it has a power. How do I address the power? What? Exactly. 2 comes in front as a factor. So 2 log base a of x minus. Careful. If it has a product, I have to address the product first. So I have log base a of a product. What do I write? Log base a applied to exactly Exactly. You can, I accept that, but let's illustrate step by step. And then I have log base A of z cubed. There is only two things, I should say, only two more things we have to perform here. We have to distribute the negative sign to both quantities in brackets, and we have to apply the power rule. So quotient rule was eliminated. Power rule, product rule was eliminated. And now there is one thing left, distributing and applying the power rule. So what is the simplified form? 2 log base A of x minus log base A of y minus 3 of z. Excellent. This is completely expanded. There are no more rules that I can apply here. Quotient, product, and power. Okay, so let's choose another from 19 through 44. That's the answer. It's completely expanded to simple logs. No more properties can be applied here. There's nothing left. So now the other way. So would you like to choose another? So 19 through 44. You want to choose another or we move on?
42?
Yes. 42. Log of the square root of x, the square root of y, the square root of z. I thought we banned him from choosing some time ago. Didn't we do that?
We did. Maybe. I can't remember.
Okay, perfect. So here's how we start. Very good problem, actually. Thank you for choosing that.
That looked up.
Very good. Okay, so I have log of square root of blah. Right? So is there any other way I could present this? So I have blah raised to which power? Exactly, that's my starting point. I will have to change the square root into whatever to power 1/2. That's my first step. Excellent. We have to do this step by step. We cannot draw any conclusions yet. So I copy everything I see. I only change the first radical into blah, blah, blah raised to 1/2. Perfect. Now, I have an expression raised to power 1/2. So I have to apply the power rule.
So 1/2 power. 1/2 log.
Exactly. So 1/2 log x, the square root of y, the square root of z. Excellent. Now, again, I look inside. When I look inside, I have to decide what I see. Do I see a product? Do I see a ratio? Or do I see a power? I see a product. Excellent. So I have this product of this and this, correct? Perfect. Excellent. So then I have 1/2 in front. I need brackets now. Be very careful because at the end I have to distribute that 1/2. But right now it's waiting. Okay. So please tell me what I write in brackets. Yes. Exactly. Yes. Exactly. Perfect. At this point, there are several options. You can distribute 1/2 plus 1/2 log the square root of y, the square root of z. This is completely done. Would you agree? No one can do anything else here. Okay, now I'm back to the second log. And here's how I look at it. Does it have a product, a power, or a ratio? It's a power, right? It's the square root. So it's not a product. I can't look inside just yet. I have to start slowly from the outside and walk my way into inside. Okay, so now this is 1/2 in front, log x plus 1/2 log blah, 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 raised to which power? Yes. Yes. So y the square root of z. Are we okay so far? Good. So now, 1/2 log base x plus, exactly, thank you, 1/4. And now, inside, yes. So what will that be? Log, it's a product, right? It's a product plus, very good. I will distribute 1/4, and I only have one more step to go. I eliminated, I don't have ratios, I don't have powers anymore, but I have a power. I don't have products anymore, but I have a power. Yes, pardon?
So when you move the 1/2,
I have to multiply by 1/2.
you have to multiply.
I already have, because they're all factors.
Okay.
I bring in another factor. Yes. Look what he did to us. Whole page. But this is the only way. Do you understand that we cannot draw any conclusions, and we have to work our way very slowly through this problem? So 1/2 log x plus 1/4 log y plus 1/4 log of z raised to, right. Exactly. So 1/2 log x plus 1/4 log y plus 1/8 log z. There is another way. You can go back and just take the expression on the side and change it into exponents. So if that works better for you, you can. You have to be very careful with this one. Good, let's do some condensing now. We're going backwards from 45 through 54. 45 through 54. We're going backwards. We are given, in other words, all this, and we have to come up with that. You will.
46.
46. Let's start out slowly. Okay, 46. So we have log 12 plus, it's 1/2 in front, right? And minus log 2. Perfect. When we go backwards, the first step is always the number in front of a log, if I have any. The first one has nothing in front. It cannot do anything to it. The second one has 1/2 in front. And the last one doesn't have anything in front. Good. So then that's my first step. Exactly. Log 12 plus log square root of 7 minus log 2. Excellent. Now I look at the first two, and they have positive in between. How do I condense them going backwards? What does that mean? Where does this sum come from? Yes, it comes from log of, exactly. Exactly. Because log 12 the square root of 7 is log 12 plus log the square root of 7. Now we have a difference. Where does that come from? Right. So it's log. Right, but careful, not outside of the log. The expression is still inside the log. And now I'm allowed to simplify because these are factors. So the simplified form is log 6 the square root of 7. And no one can further simplify this. Or we don't have other properties to apply backwards. Anything else? From 45 to 54. Yes, of course. And we will take you on. We're 1, 2, 3, 4. Which one? Okay, I'll choose 53.
53, that's what I was thinking.
See?
They were on the same wavelength right there.
Yeah. I went ahead.
No, you mean like.
Yes, look, this one looks awful. It's not. So it's 1/3 log x plus 2 plus 1/2 and brackets log x to the 4th minus log x squared minus x minus 6, everything squared. Where do you think we should start? Exactly, of course. And also, you can start with the 1/3 in front of the first log because they're not connected right now, right? So you would say log of what will the 1 power? The cube root of x plus 2 plus 1/2. Let's see what we have in brackets. Log of what? It's a minus.
Oh, so it's by the log x to the 4th, not divided by every log x.
That's it. Good. What will be my next step? To get rid of?
That 1/2.
Exactly. What does that mean?
It means you're trying to square root of that whole.
Exactly. How much is the square root of the top?
X squared.
How much is the square root from the bottom?
X squared minus x minus.
That's it. Final step.
And then we just multiply the cube root x plus 3.
That's it. But put the cube root after x squared. It is because it's a sum. This has to be at the top because if you put in a denominator, you will have a negative sign in front.
I thought it just like they went side by side, like multiplied.
Right.
Oh.
Yes.
So,
X cubed, the cube root of x plus 2 over 1
yeah.
times x squared over x squared minus x minus 6. But we put the cube root at the end. Any questions? Quite straightforward. Would you agree? It may be a little bit cumbersome sometimes, but there's these 3 properties belong to log. No other function has these properties. Yeah. Okay, ready? Okay, exponential equations. Exponential and log equations. I'm going to start with the simplest possible one. And there is nothing easier than this. What does this imply? Two numbers are equal and they have the same base. Can this be 15? No. So what should x be? That's it. We're not going to find anything easier than this. On page 338, page 338, I need to make a couple of equations up because I don't want to move into difficult ones before I show you a couple more. So here's another example. And you can say, wait a minute, this looks very difficult. It's not. Here's the answer why. both sides can be presented with the same base. Okay, the left-hand side, I need the base to a power. Instead of 1 over 8, I want you to tell me write this to this power. Yes? Yes, but since it's in the denominator, that's it. I would like the same thing on the other side. And it better be the same base. Otherwise, yes, 2 to the, yes. We are getting there, right? The first one was the simplest possible one, right? We didn't have to do anything. We just had to think. We did not eliminate the bases. We only thought. Two numbers are equal and they have the same base, therefore their exponents have to be the same.
So you can multiply that.
Exactly. So 2 raised to which power?
Negative 3 minus that plus.
Plus 3.
Yeah.
Good. 2 raised to,
2
very good. And now we don't eliminate anything, we just think. Two numbers are equal and they have the same base. What has to happen to their powers?
These are equal to each other.
Exactly. So negative 3x plus 3 must equal 10x plus 20. Linear, I move terms around. Negative 13x equals 17. X equals negative 17 over 13. It was just linear. I move terms around and I divide it. Okay, now we're ready for more complicated situations. Now you feel free to choose from 3 through 28. This is page 338. Okay, let's start with 10. Very good. 2e to 12x equals 17. Very good pick. You still have green light to choose. We only removed it from one student. Okay, very good, excellent. If you remember, we always try to simplify or factor, right? Always. We always have that in the back of our minds. So I see on the left-hand side a product of 2 times an exponential function. I don't need that 2 in there. And you can say, but it's not, you can divide both sides by 2 because 17 is not divisible by 2. True. But I will still divide both sides by 2 because I want a clean exponential function on one side. So now I'm asking myself, can I write both sides with the same base? Of course not. This is base E, and this is 17 over 2, which is 8.5. E is 2 point blah, 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 7, 1, blah, blah, blah. And this is 8, right? 8.5. So both sides, no, cannot be presented with the same base. They cannot. There must be a mechanism that still allows me to change this into a linear equation. That's the purpose. Okay, so now let's look at both sides and say, let me give you a couple of examples to see if you're on the right track with me. If I want to solve the equation sine theta equals 1/2. Yes, you can say you go back to the unit circle, blah, blah, blah. But what am I really doing here? Exactly. Very good. I apply sine inverse to both sides. Excellent. What do you think I should apply here? Exactly. In which base? Exactly. It doesn't matter. But since I see E or base 10, I should apply the corresponding one. It doesn't matter. The answer will be the same. Okay? So I have to apply, like here, the same function to both sides. So if I apply natural log here, I have to apply natural log here. Now, if you remember, log has that amazing property that allows us to take the power of the quantity inside and put it in front as a factor. So what will I put in front as a factor then? Indeed. 12x times natural log e equals natural log of 17 divided by 2. Now let's figure out how much is log e. What is the base? Exactly, it's 1. So e raised to which power is e?
Yeah, it's
1. So this is another property that is very important. Log base a of a, log in any base of the base will always be 1. Log base 5 of 5 is 1. Log base 10 of 10 is 1. 10 raised to which power is 10? So now this becomes a linear equation. 12x equals natural log 17 over 2, and I divide both sides by to get the answer. By? Exactly. If I want an approximation, I must use the calculator. So if I want natural log, I'm going to put 8.5 and divide by 12. And I get approximately 0.1783. Very good pick. Anything else? The most difficult one is 23 and 25, 26. These are the most difficult ones. Which one? Okay, so let's start with 26. And then we'll go back to 23. 10. Everything divided by 1 plus e to negative x equals 2. Now here's my hint. What am I telling you with this? Exactly. Exactly. This is a proportion. So cross multiply. So what will you write? 10 indeed equals, do not distribute, quantity, 1 plus e to negative x. Do we accept this? What do you think I'm going to do with that specifically? I said don't distribute. Right. I will divide both sides by 2. What do I get on the left? Perfect. What do I get on the right? It's not cleaned up in the exponential sense. What should I do next? Not yet. Remember, that's a very good point. Remember, we have only 3 rules. Log applied to a product, log applied to a ratio, and log applied to a power. If you apply it to a sum, you're stuck. You can never simplify it. Log of a plus b, you have no rule. Log of a minus b, you have no rule. So then, exactly. That's what I said. It's not cleaned up yet. So I have 4 equals e to negative x. Now I'm ready. For what? Exactly. Exactly. Let's say we choose not to apply base e, but let's apply log. It will make no difference. The expression will look a little bit easier with natural log, but it's okay. It doesn't matter. So the left-hand side is log 4, and the right-hand side will be negative x in front, right? Log e. Perfect. And now, final simplified form, x equals negative log 4 over log e. If you use the natural log, it's fine. We're going to get the same answer. So let's determine this. Negative in front, log 4. Divide. Do not make the mistake to put log 4 over e. It's log 4 over log e. Totally different. Okay? So log e. Here's e right here in the division symbol. Same key with the division symbol. So negative 1.386 approximately.
we just use natural log.
Yes.
Log E is good.
And you're going to get the same answer.
Okay.
Plug it in. Did you plug it in?
Oh, I did plug it in, yeah.
Same thing. Okay, I would like to go to 23. 23 is the most difficult type, and we can, after that, if we still have a few minutes, so we can start logarithmic equations. Okay, 2 raised to 3x plus 1, they say is 3 raised to x minus 2. Okay, ready? Can I present 2 and 3 with the same base? No. So what is my only chance then? And it doesn't matter which one you apply. But you have to bring the power down. And there is only one function that will allow us to do that. So then I have to apply what to both sides? Same thing what we did here. Yes, any of the two. Which one you prefer? LOG? Okay. Now the next step is absolutely crucial. If you do not put parentheses, when you bring this quantity in front, if you don't put parentheses around it, you are not going to distribute to all of them, right? So what will be that next step that I have to write?
3x plus 1.
In parentheses,
Log
log 2 equals?
x minus 2 and 3 log.
Exactly. Do not be bothered or get bothered by log 2 or log 3. They're just numbers. But we don't want to approximate them. So at this point, I will have to distribute. So I distribute log 2 to these two quantities. 3x log 2 plus log 2. Any questions so far? And now tell me, what should I write on the right-hand side?
X log 3
Minus.
minus 2 log 2.
Although it looks maybe weird, it's still linear. It's linear in x. There is nothing major here that we need to do. But I need to switch terms, move terms around. So this term has x. This one has to be next to it. This term doesn't have x. It has to be next to the other one. So then what will be the next step after I move terms around? What will you write?
Log 2
3x log 2. Yes,
x log 3
very good. Equals.
negative 2 log 3
Yes,
minus 1.
good. Perfect. I can combine the left two, but I can do something else. What is something else that I'm referring to? There are two keywords in algebra and pre-calculus and calculus. Or the other one is? Okay, so which one?
Vector.
What? Exactly. That's it.
Question real quick.
Yes,
Why didn't you switch them on the different sides?
it's linear. The equation is linear. I have to have x on one side and no x on the other.
That's it.
Since I cannot combine them, what do I get?
3x log 2 minus log 3.
I copy the right-hand side.
Negative 2 out. Oh. Could you pull negative out and make it linear? Or does it matter?
You mean, say it again?
Like if I factor in negative 1, just make it 2, negative 1.
Here?
Yeah.
Yes, but you look what happens. How much is x? Yes, you can put the minus in front. Then the top will be 2 log 3 plus log 2 over this. If you want to approximate this, you have to be very careful. You need parentheses around the top. I'll stop in 1 second. This is the last thing. And parentheses around the denominator. Be very careful here. Parentheses around the top with minus in front. Let's put the minus in front first, and then parentheses around the top. 2 log 3. Don't forget parentheses around 3. Plus log 2. Close the parenthesis for 2 and close the parenthesis for the top. And divide by parentheses for the denominator. 3 log 2. Close the parenthesis. minus log 3. Close the parenthesis for 3 and close the parenthesis for the denominator. And you will get negative 2.94. So approximately x is negative 2.95. How do I check my answer? So here's how I do it. I will consider this. 2 to 3x plus 1 minus 3 to x minus 2 equals 0. I moved this term to the other side. And I will plug in x using the previous answer. Okay, here it is. So 2 caret 3 times the previous answer plus 1, close the parenthesis, minus 3 caret in parentheses, previous answer, minus 2. When I close the parenthesis and hit enter, what should I get? If that's the correct answer. Okay, so it is. I will see you. Thank you. I will see you